Morning, Jeb.
Morning, Rel.
Morning, Melody.
Saba, Rel, be.
De wow.
Si Usi Bay.
Rel,
One.
Rel,
Okay, so good morning, everyone.
Morning, sir.
Good morning, good morning. So,
Good morning, sir.
yeah, good morning, good morning. So, uh, we'll be discussing about the formulas involved in calculating magnetism and electromagnetism. So, I've said that I will be separating the principles of calculations. So, let's focus on the calculations today. Please tell me if it's visible na sa inyo, ah.
Makita mo.
Okay. Let's talk about calculations involving magnetism and electromagnetism. So, some of the topic from electricity might come in handy in this discussion. So let's go back on discussing about magnetic field of a solenoid. The topic about magnetic field of solenoid is a solenoid consists of coils of wire. The direction of magnetic field lines is represented by the lines of force. The quantitative measurement of the strength of the magnetic field depends on the amount of the magnetic force exerted by the field in a test charge. So if you go back on the activity where the use of your hands, gripping something, okay, if you grip your hand, uh, you can possibly say that those fingers that are gripped, those are the sample of a solenoid coils, okay. These are the coils of wire, for example. And then we have here your thumb as, let's say, as the source of the current. Let's say it's a product of the force, okay? And then also, as we created this, as the force started to meddle in the presence of this, let's say, this solenoid, which is your fingers. Inside those fingers now are the electromagnetic, let's say, I'm sorry, it's the magnetic field. Okay, it's the magnetic field. Now, why is it that the force is involved in this formulation? Again, the magnetic force there is, let's say, it's the cost of why the current was formulated. So, if the current now is formulated, it will now flow to the coils of the wires. And then under the kwan na yun, it is now, let's say, the magnet that is actually kanang kwan ga subay that tong kwan under sa kwan or ilalom that mga coils of wires is now regulating the flow of the current. Okay? So in a given magnetic field, the magnetic force is directly proportional to the charge and velocity of the test particles. Uh, since we have a presence of the current here, so it means that the particles involved in the current was really moving, from let's say from the south to north or north to south. Depends on which is the source coming from. And then to represent that one in a mathematical figure, we have F is equals to B for the magnetic field times the charge times the velocity. But if we will be, let's say, if we simplify it, okay, the idea of this formula, we can actually say that, so, uh, for example, we have also here, so Q here is the test charge in column. Of course, it's given. We also have here the velocity, or just V, that is meter per second. And the B here is the magnetic field strength in Tesla, and the F is the magnetic force in Newton. Since the velocity of the test charge can be measured by the length divided by the time, and the length that we are referring to here is the length of the coil, for example, involved in the process, then we can possibly say that F is equals to B times the charge or the Q multiplied to the dissect na velocity, which is L time or L divided by T. So in short, we have F is equals to B times Q times L divided by T. But since Q divided by T is the formula for the current, or I, we can now have F is equals to the B multiplied to the I, which is the current, then multiplied to the length, which is, let's say, the length of the coil again. So our final formula here can either be F is equals to B times I times L, or F is equals to B times Q times L divided by E. Okay? So the use of this formula class is dependent on the problem given. So not all actually is providing the real idea kung si pangitaon sa mga formula given. So for example, no, most of the problem set, they are not directly talking about current. So they will give you some given nga charge lang and then time. So you have to at least have an idea on how are you going to simplify or understand what is given. But if you are so familiar with the formula, and I think makuha na lang diretso ko sa pangitaon. So let's apply that formula in this given problem set. We have a conductor that is 1.5 meter long and it carries a current of 0.5 ampere. Calculate the strength of the magnetic field if a force of a 0.004 Newton is exerted by a uniform magnetic field perpendicular to the conducting wire. So, from the given, we have 1.5 meter for the length. For the current, we have 0.5 ampere. And for the force, we have 0.004 Newton. So, we have to find for the magnetic field strength, or the B in Tesla. So, the solution will be F is equals to B times L. Since we're looking for the B, we need to derive a new formula. So to get the B here, we need to divide both sides by current and length. So we have F is equals to B times I times L. Divide both sides by I and L. Cancel the IL, then you'll have B is equals to F divided by current times length. Okay? Naka-follow ba sa process? Okay. Now, after deriving a new formula, let's now have the substitution. So we have 0.004 Newton for the force divided by our current, which is 0.5 ampere, times our length, which is 1.5 meter. And then 0.5 times 1.5 is 0.75. So we have 0.004 Newton divided by 0.75 ampere meter. So our product now will be 0.0053 Tesla, which is the unit for the magnetic field. Please check if we are having the same answer.
Yes.
Okay. So did I make myself clear in calculating for the magnetic field and force?
Yes, sir.
Okay. Again, all you need to do is to familiarize the given formula. If you know how to derive a formula class, you can actually understand what is the problem set is looking for. And then, for example, you have this one. For example, you have to look for the length, but the given here is aligned to the given, which is let's have we have a magnetic field strength in the given, we have a force in the given, and we have a current given, but we don't have this length. So, kana siya. So, what do you call this one? So it's very simple for us to look for the length because all we need to do is to derive a new formula. And then we can also, actually, we can formulate a lot of a derived formula out from the original. As long as we are, as long as we know what we're looking for. Okay, before I expose you to the other formula, let's have first this free body diagram. I want you to analyze this figure. So we have here two samples, but actually the idea here is only one. So We have here a BFI, which stands for the magnetic field for the B, force for the F, and current for the I. So, in this matter, Manggod, kung siya, no? Daling a figure, Manggod. We have a force here that is interfering the process that is happening between the magnetic field and the current. Let's say, for example, the force here is actually affecting the presence of the current, no? Because again, the force is the reason why the current is formulated. And then the magnetic field here is actually also affecting the presence of the current because it regulates the let's say the way the current is flowing in a specific material. So this diagonal line here that is where the force is involved is actually creating this what we call angle, no? So the actually angle nga ma-form. But the magnetic field, Manggod, is only the magnetic field. The direction of the magnetic field can only be happen in a counterclockwise or clockwise direction. So it means that bisa pag i-place nato ni siya in this manner, which we will always have this the same situation. Okay, an angle will be formed at the same time. So to relate this one, we have here what if angles involved in calculating for the magnetic force. No? What if the force now is diagonally influencing the magnetic field and the current? So for us to understand more the concept of why magnetic force is diagonally, for example, interfering the connection of the field and the current, we have this problem set. Okay, a 2 meter straight wire carries a 30 ampere current and is surrounded by a magnetic field strength of 0.8 Tesla. Calculate the magnitude of the magnetic force on the wire if it is placed between the pole ends of two magnets at an angle of 45 degrees. Okay, so what will be your answer here? So using the formula, no, F is equals to BIL times the sine theta. So the only thing that was added here is the sine theta. So I'm gonna sine theta naman, sir, because again, magnetic field can only do the counterclockwise and clockwise let's say direction, but not totally on the whole circular kind of motion jud. Like pagbalik-balik din yung motion at the same time. Okay, now let's have the given. So we have I, which is current, which is 30 ampere. We have the Tesla, which magnetic field, I'm sorry, which is 0.8 Tesla. And then we have an angle of 45 degree, like that is where the force was placed. And then also we have a length now of the conductor, which is 2 meter. Now the question is, we need to find the F, or the magnetic force. So using the formula, F times B times I times L times sine theta, substitute the given values. So we have 0.8 Tesla times 30 ampere times 2 meter. And then kindly check the class if the sine theta here is 0.707 joule. Sakto ang sine theta nga 0.707. Sine 45. Hello. Is it 0.707 ang sine 45?
Yes, sir.
Okay. So we have 0.8 Tesla times 30 ampere times 2 meter times 0.707. So we have 33.936 Newton or 33.94 Newton in force. Okay, so that is the force influencing in the diagonal direction of the magnetic field strength and the current. So, 33.94 Newton, no, ang gigamit para lang makakreate ang current nga 30 ampere, okay, with respect to the presence of the magnetic field strength of the material. Okay, so, nakuha na ang nakuha na ang connection sa involvement sa angle in calculating for the magnetic force. Before I proceed to the next example. Okay, how about this one? Can we answer this one, Dokuno class? What if you have a 4-meter straight wire carries at 30 ampere and it's surrounded by a magnetic field strength of 0.10 Tesla? Calculate the magnitude of the magnetic force of the wire if it is placed between the pole ends of two magnets at an angle of 65 degrees. Try to answer that one, Dokuno. Okay, what's your answer? Anyone who has an answer already? Pila? Okay. Thank you, Budlaw, with your answer. How about the others? How about sa uban? Okay, the same with Binyosa. Okay, so actually we have an answer of 10.87, or let's say 10.88. Okay, or 10.87, because the answer is 10.8756 man. So we have 10.87 or 10.88. So very simple very simple to solve, because all we need to do is to, okay, thank you, Carol, with your answer. Your answers are correct. Okay, so very simple, because all we need to do is to multiply everything. So we have 4-meter times 30 ampere times 0.10 Tesla times the sine of 65 degrees. So our answer now is 10.87 or 10.88 Newton. Okay, Newton, because it's a force. So we have Newton. Are we having the same answer? How about the others day? Kanila ba sa tulong ng answer? Okay. Now let's proceed to the magnetic flux. Okay, you've heard already the magnetic flux in the word, no? As we discussed the electromagnetism and the magnetism at the same time. A magnetic flux is something that is inside. No? It's already on the magnet. But the problem is, how is magnetic flux affected by the magnetic field or the strength of the magnetic field in Tesla with respect to the process of the force, which is actually the reason why there is an either an increase or a decrease of the magnetic field strength, and also the formulation of the current, and how is it also, and why is it that the area is part of the process. Now, coming from the formula of magnetic field, which is B is equals to the magnetic flux divided by the area, all we need to do is to derive a new formula. So we have the magnetic flux is now equals to the magnetic field strength in Tesla multiplied to the area in meters squared. Why do we need area here? Because we are looking for the magnetic flux unit, which is Tesla meter squared or Weber. Okay, area is also involved in this process class because we're talking about again we're not talking about a rectangular shaped magnet bar only. There's a lot of shapes for to represent the magnetic bar. It can be either a sphere, a C shape. It can be also depending on what shape it is. Okay, because the magnetic flux again is inside. It is already it is already the object. But what we're talking about here is that how is it being influenced by the presence of the magnetic field, okay, which is in Tesla, which is the force can also be a factor that can produce current and can increase and decrease the amount of strength for the magnetic field. Applying the formula for magnetic flux, so we have here an iron bar with a cross-sectional area of 0.05 meters squared. Let's say, for example, this is a perfect square na magnetic bar. It is placed in a magnetic field of 50 Tesla. And what is the total line of the magnetic flux of the iron? So from the given, so identifying the given, we have area, which is 0.05 meters squared, and then our magnetic field strength, which is 50 Tesla. Just substitute the given values, 50 Tesla times 0.05 meters squared. Kung balo kang multiply, makuha mo ang 2.5 Tesla meter squared or Weber. So, nasabtan ang process on calculating the magnetic flux. Hmm? What do you mean other ko sa Tesla? Ay, ang other kwan, ay ang other kana possible na maging kwan. Okay. Sa Tesla Mangkot class, I think sa Tesla Mangkot is that Tesla is the combination of the force, the length, and the kwan, and the current. So if you have the force, you have the length, and you have the unit of ampere, no? So you can also have the combination. Say, let's go back para Danny. Okay, if we will be uh, if you will get the formula of the let's say the other unit for the Tesla here in this particular nga kana formula, it is fun. It's safe to say that we have on getting the Tesla unit. First, we have the Newton. And the Newton, di ba? Sa Newton, magod is na kay kilogram meter per second squared. So, nanatay pondo na to. So, the ampere here of the current here is also let's say, it's also the product of the charge in column divided by the time. So, we have now the column per second. So, we have now kilogram meter per second squared, and then column per second. Okay? And then also we have here the length, so meter. So if you will if you'll be combining the idea of this one, so naatay Newton meter per second squared per, okay, that's per column meter per second. Nakuha, Philip, ang kuha sa Tesla. So in short, na kay Newton per column per meter per second. Oh, no, column per meter second. Or kilogram meter per second squared. Tapos per, okay, column per meter in seconds. So, wala siya, kwan ba? Actually, taas kayo siya. Napay pwede kwan. Atong ikwan. Ato na siya i-dissect. Thank you for asking for that, Philip. So, Newton, we have kilogram meter per second in squared. Uh, for the kwan, for the I, we have, let's say, we have column per second. It's because it's Q divided by T. You know? And then also we have, for the length, we have in meter. So from the formula, F is equals to BIL. And then if you will be getting the B, so we have B is equals to force divided by IL. So let's try to find kilogram. It's better to learn this one class kay base magod sa mga problem sets in the future. You'll be exposed with this given. Kasi maghatag sila mass, di ba? Maghatag sila mass, maghatag sila og kwan, maghatag sila og, what do you call this one? Maghatag sila og different kanang given. But you are trying to solve only one. You're only looking for one. Okay, so what will be the best thing that we can do here? Actually, wala tayong ma-cancel, Danny. Di ba? So, may mo na siyang, okay, what tayo ma-cancel, Danny? So, may mo na siyang kilogram meter squared per second squared divided by column per seconds. Or kilogram meter squared per second squared per column per second. Oh no, actually we can remove the seconds here, Taytuod. So kilogram meter squared per second per column. Kana. That could also be the unit for Tesla. If ato siyang ato siyang isa-isahon. Okay? So let's try to remove the presence of this this seconds here. And then we'll try to multiply this one dito sa ang mass sa isa. So, kilogram meter squared per seconds per column. Yeah. So, kwan siya, class, kilogram meter squared per second per column. So, or in short, Tesla. Okay? Because sa atomong magnetic flux is we have Tesla meter squared or Weber. So, we have for the one, for the Tesla, we have kilogram meter, or let's say, okay. Let's remove the meter on this one sa ato sa tong B. Okay? So we cancel out the M or the meter because we need to we need to stick on the Tesla nga kwan. Ato na siya ininayo na. So let's remove the meter here. So cashing out the meter, so we'll have now kilogram per second squared per column per seconds. So for the magnetic field, the presence of the kilogram here is okay. It's here, and then also we need the charge at the same time, so it's here, and then so let's finalize this one. So we have kilogram per second squared per column, or kilogram per seconds sa man sa S1. Sa division ba sa denominator, if may I ask, maad ba ang ilahang exponent nga 2 ug 1 dani or ma-minus? Minus, no? So kung na siya per kilogram per second per column. Yeah. So it's like kilogram per current. So mass times current, mass times I. I think that is the product of the quant. That is the product of the magnetic field. Because, di ba, ang column per second is only for quant. It's only for the column per second is initially a current. So it's ampere. So kilogram ampere. And that is the Tesla. Because we remove the presence of the quant band, we remove the presence of the mass, and we also deducted the presence of this time on the squared. E squared then is ato ang force. So, okay. So we have kilogram in ampere. Kilogram per ampere. So yan na yung answer. Kilogram meter seconds per column. If we will, the column per second is an ampere per current. So it's kilogram ampere. Kilogram or ampere per kilogram. That could be also the other unit for the magnetic field or Tesla. Okay. I'll be checking on that one siguro later. Thank you, Philip, for asking, Philip. No? Ato na siyang i-quan class para naatay other option as well if you'll be asked on the different, let's say, unit, no, in a given problem set. Would it be okay? Okay, sige. Sige. Okay, so let's just like magnetic field class, we can also include angle, especially when you're calculating the magnetic flux. So if the magnetic flux is affected by the presence of the force, then let's say that uh, there will be a change in the there will be an angle involved with respect to the area. Nga, pwede na itong makalculate, no? Because like this one, in this Fleming-Hance rule, if we have this concept of Fleming's, actually the motion here is affecting the connection of the field and the formulation of the current. So in this time, we are not actually focusing on the current here is actually missing. Pero, there's a pero what if no, the product of the current here is actually diagonally the direction of the current here is diagonal. So let's try that. Let's say that we have here the current, okay, the flow ang current via outside, no, between the force here and the magnetic field, okay, na naada ni sa usa ka cross-sectional area. For example, this is a square magnetic bar, and then naatay pole, for example, a metallic pole that was connected in this area. So girab ang pole in a circular manner, okay? And then the magnetic field now will be formulated inside this area. And then let's say that we have a coil here that is connected. The coil here now will be the coil here is now because of this force, now because of this pole rubbed in this area, na current ng flow bali on that coil. So the current now is flowing outside the area. So let's say that the area here na siya angle na na-form. Ano siya dani? Kani nga direction niya. So we have here a magnetic flux is equals to the magnetic field, okay, times the area and the cosine theta. The angle involved between the magnetic field and the force. So this is, let's say, for example, this is the current that is flowing outside the area. So atong balayon si Fleming left hand rule. So ma-reverse ang iyahang direction. So may mo na siyang nasa taas si field, naa si motion sa pa left, and then naaran si current paingon sa imuha. Okay? It's facing you, for example, or facing outside. So that's the reason why we have a cosine theta here, because it is now involving an angle. But sir, nga cosine itong gamit na ni. It is now because in a area mo go sa circle class, this type of formula can also be performed at a different angle. Either in a 90-degree angle, either in a 360-degree, 180-degree, 60-degree, 30-degree, whatever degrees it is. Let's say that since the magnetic flux is inside already on the object, then the flow, for example, of the direction of the current can either be on the different direction as well. Okay? Pwede siya dani mo gawas sa pikas, pwede siya sa ubos, pwede siya sa left down, right down, pwede gapon siya sa left up or right ups, kana. Okay? But for the better understanding for the concept of the magnetic flux involving the angle, okay? So we have here a sample problem set. Okay? Calculate the magnetic flux through each squares. If we have 50 centimeter on each sides, so the magnitude of the magnetic field is 10 Tesla, and the angle is at 40 degree. So what do you think is the answer here? So from the given, we have a magnetic field which is 10 Tesla, and then an area of 0.5 meters squared. Okay, so we just converted, no, the 50 centimeter divided by 100 centimeter to 0.5 meter. So let's say that the meter here is since the unit of area is in meters squared, man. So we have 0.5 meters squared. Just change the unit, no, to centimeter squared here. And then we have a 40-degree angle. So solve for the magnetic flux. So we have 10 Tesla times 0.5 meters squared times cosine 40. So our answer here is that multiply everything, then you'll have 3.83 Tesla meter squared or Weber. Kindly check na if we are having the same answer. Okay, same siya. 383. Okay. Okay, how about this one? How about you try this one first? How about if you find the magnetic flux of a square object that is 100 centimeter in area. If the magnetic field is 45 Tesla, formulated with respect to the force creating 30 degrees. Again, find the magnetic flux of a square object that has 100 centimeter per side. If the magnetic field is 45 Tesla formulated with respect to the force creating 30 degrees? Okay, what's your answer? Okay, thank you, Philip. You can comment your answer, class, if you want. Kung maulaw ka magkuhan, maulaw mo magtubag. Ito naman dun. Okay, thank you, Shame Ann. How about the others? Are you having the same answer, class? 38.97. Okay. So our answer is 38.97. So, okay. Thank you. And, thank you, Philip, Shame Ann, Alexandra, Irene, Amethyst, Princess, Ayana, Joel, Angel. Okay. Your answers are correct. Okay. All of your answers are correct. We have 38.97. Because what we did is just multiplied everything, no? We have 45 Tesla times 1 meter because convert mo na to siya into meter. So, times the cosine 30. So, we have 38.97. Okay, yes, Melody, your answer is also correct. Okay. Uh, any questions so far? Atong discussion? Wala. Okay, let's go back on the other formula for the other unit for the Tesla. It's kilogram. See, Tesla is kilogram per seconds in column or kilogram per column in seconds. Dili siya kilogram seconds per column. So it's kilogram per seconds in column or kilogram per column in seconds. At least, di ba makatulog na ta? So it's kilogram per column seconds or Tesla. Okay? Okay, any more questions? Parang reactions? Wala na, so none so far. None so far. Okay, so face-to-face ito puhon, no? Next week, kumadayon na. We'll be dealing more on the calculations part sa electromagnetism of magnetism. Actually, I need to introduce to you the the electromagnetic induction formula as well. So ako na lang siyang i-face to face sa inyo pag discuss. Okay, para natin interaction at the same time. Okay? So if none, then thank you so much everyone for your attendance. I hope you have learned a little about our discussion for today. And see you again next week. Okay, goodbye everyone. Have a great day.
Thank you, sir. Bye.
Thank you, thank you.
Thank you.
Bye, sir.
Bye,
Bye,
sir.
sir.
Bye. Goodbye, goodbye, goodbye.